Exercise 1.1, question number 5. Given matrix A is equal to 1 by 9 times of minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4. We are asked to show, or we are asked to prove here A inverse is equal to A transpose. We know that if the matrix is orthogonal, result given in our textbook, if the matrix is orthogonal, A transpose is equal to A transpose into A is equal to the identity matrix if and only if A inverse is equal to A transpose. So if the matrix is said to be orthogonal, if A transpose is equal to I, then it is understood that A inverse is equal to A transpose. So for this problem, it is enough if we prove that A into A transpose is equal to the identity matrix. It implies that A inverse is equal to A transpose. So for the given matrix A, multiply with A transpose is equal to 1 by 9 times of minus 8, 1, 4, 4, 4, 7, 1, minus 8 into 4. I multiply this with the transpose matrix. What is a transpose matrix? The first column becomes the first row. So minus 8, 4, 1. Next, the second column becomes the second row. 1, 4, minus 8. The third column becomes the third row. So 4, 7, 4. Now multiply. This is equal to 1 by 81 into, I multiply the matrices first row with the first column elements. So I multiply first element minus 8 gives us 64. Next I multiply 1 into 1 plus 1. Next 4 into 4. This is plus 16. So I have multiplied the first row in the first column. Next we multiply the first row and the second column. Similarly, minus 8 into 4 gives us 32. Minus 8 into 4 gives us minus 32. 1 into 4 gives us plus 4. Plus 4 into 7, 28. So I have multiplied first row and the second column over. Next, first row and the third column. Minus 8 into 1 gives us minus 8. 1 into minus 8 gives us minus 8. 4 into 4 gives us 16. So the first row and the last column element is over. Next we are going to multiply the second row elements with the first column. So second row first column elements, 4 into minus 8 gives us minus 32. Next element, I multiply the second element, 4 into 1 plus 4. 7 into 4 plus 28. So second row, first column over. Next second row, second column. Second row, second column. 4 into 4, 16 plus 4 into 4, 16 plus 7 into 7, 49. So similarly, multiply the second row, last column, 4 minus 32 plus 28. Next, I multiply the last row with the first column elements. Last row, first column, minus 8 plus 16. Next, last row, second column, 4 minus 32 plus 28. Last row, last column gives us 1 plus 64 plus 16. Now adding the elements, 64 plus 1 plus 16 gives us 81. Next, minus 32 plus 4 plus 28 gives us 0. 24 plus 4, 32 minus 32, 0. Minus 8 minus 16 plus 16, 0. Minus 32 plus 32 gives us 0. Plus 16 plus 16, 32 plus 49 gives us 81. 28 plus 4, 32 minus 32 gives us 0. Minus 8 minus 8, minus 8 minus 8, 16, 0. Next up 4 minus 32 plus 28 gives us 0. 16 plus 1, 17 plus 64 gives us 81. Now take 81 outside. 81 by 81 into 1 0 0 0 1 0 0 0 1. Now this is the unit matrix. A transpose we got is equal to the unit matrix 1 0 0 0 1 0 0 0 1, which is equal to the identity matrix of order 3. So here A transpose is equal to I implies A inverse is equal to A transpose, and hence we have proved the result. If a matrix is orthogonal, then A transpose is equal to I implies A inverse is equal to A transpose. Next problem. Question number 6. Given A is equal to A minus 4 minus 5 3. We are asked to verify A into a J is equal to adjoint of A into A is equal to determinant of A into I2. So first we find for the given matrix, we find what is edge of A. So here for given A, edge of A is equal to, the shortcut method. So we are going to interchange the elements of the diagonal. So interchanging the diagonal elements, we get 3, 8, change the sign of the non-diagonal elements. So I get here 4, 5. This is edge of A. Now next I am going to find what is A into adjoint of A. It's equal to 8 minus 4 minus 5, 3 is the A element into adjoint of A, 3, 4, 5, 8. So multiply first row, first column elements gives us 8 into 3, 24 minus 20. Next first row, second column elements 34 minus 32. 8 into 4, 32 minus 32. Next minus 5 into 3 minus 15 plus 15. Next second row, second column elements minus 20 plus 24. Now this is equal to 4 0 0 4. This is A into a J, equation number 1. So we have found what is A into a J. Next we are going to find what is A J into A. J into A. So edge A we have found already. What is edge of A? Edge of A is equal to 3, 4, 5, 8 into A matrix. A minus 4 minus 5, 3. Multiply first row, first column. This is 24 minus 20. Next first row, second column gives us minus 12 plus 12. Next second row, first column gives us 40 minus 40. Second row, second column elements minus 20 plus 24. Now this is equal to 4 0 0 4. This is equation number 2. Next, determinant of A. We are going to find what is determinant of A. That is determinant of 8 minus 4 minus 5 into 3, which is equal to 24 minus of minus 20. So 24 minus of minus 5 minus 4. So this is minus 20 is equal to 4. Determinant of A is equal to 4. Now determinant of A into I2. So determinant of A is 4. I2 is 1 0 0 1, which is nothing but is equal to 4004. Equation number 3. So from 1, 2 and 3 we get here A into edge of A is equal to 4004, and J into A is 4004, and determinant of A is equal to I2 is also 4004. Hence A into J is equal to J into A is equal to determinant of A into I. Hence proof.